Anytime you're looking for an answer, you can always use not only factoring, but also what we call the quadratic formula. Negative b plus or minus b squared minus 4ac all over 2a. When you're given a quadratic equation, again, a is whatever's in front of x squared. There's understood to be a 1 there. B is whatever's in front of x, and C is whatever number is being added or subtracted at the end. So A is 1, B is negative 8, C is 12, and we just plug that in. And reminder, we always plug into B squared minus 4AC first. For the fact of, if you get a negative right there, you're done. No solution. B squared minus 4AC, help me with this. Claudia, B squared. What is negative 8 squared? Close. Positive. It's negative times negative, be positive. And I go ahead and put my minus there. Now I've got to do 4 times A times C. Stephen, 4 times A times C. A was 1, C was 12. 4 times 1 times 12. Stephen, what do you get? Not here. Vanessa, do you get it?
Can you repeat that?
4 times 1 times 12.
I got 48.
48. So we get 64 minus 48, which is 16. B squared minus 4AC is 16. We're not done. That's leading up to our answer. Now let me show you something else. And this is kind of helpful. Is there something special about 16? Notice where that's at in your formula. Oops, I forgot the square root. There's a square root over the top of that. B squared minus 4AC is what I call the discriminant. The discriminant is always located under the square root symbol. What's special about 16? It is a perfect square root. We know the square root of 16. You know what that tells you about this problem? You could have factored it. Anytime you get a discriminant that you can find the square root of, that problem would have been factored. Okay, and you could have worked with the other method. But honestly, since you've gotten this far anyway, I'll just finish it up using this method. So here we go. X equals negative b, that is negative, negative 8. Two negatives make a positive in math. Not in real life. Not two bad things. Thank you, so turn out good. You have the square root of what is 16 underneath there, which is 4, over 2 times a, 2 times 1, which is 2. There's your two answers. And again, we arrive at two answers because of the plus minus. Your first answer being 8 plus 4 divided by 2. Your second answer being 8 minus 4 divided by 2. My first answer, 8 plus 4 is 12 divided by 2 is 6. Second answer, 8 minus 4 is negative 4 divided by 2 is negative 2. That's the exact same two answers you would have got from factoring. Correction. 8 minus 4 is not negative 4. 8 minus 4 is positive 4. 8 minus 4 is positive 4 divided by 2 should be a positive 2 though. I did that for a reason. Not really, but we'll go with that. What I did is I looked up there and I actually factored in my head. And I said, you know what, x squared minus 8x plus 12, that's going to factor into, and that's how quick factoring is. Solving it by factoring. Adds to give me negative 8, multiplies to give me positive 12, that's negative 6 and negative 2. So that factors into x minus 6, x minus 2. Move your move your minus 6 and your minus 2 over. Both of those answers should have been positive, so that's how I caught that. Okay. Let's work another one. Let's try this one. And again, we always start out with b squared minus 4ac. And that's actually also going to tell you if it's factorable. If you can solve it by factoring. Abby, what's b squared? Good. Minus. The minus is built in. 4, Ethan, 4 times a times c. What do you get for 4 times a times c? 60. 64 minus 60 is 4. Your discriminant is equal to 4. Would that be factorable? You know the square root of 4? Sure. Yeah, you could have factored that. We actually solved it by factoring the other day. Something else, I wrote this down for a reason. If you don't know what 12 times 5 is, that's fine. Why not do 4 times 5 is 20 times 3? Remember that multiplication is commutative. You can multiply, that's your algebra tidbit for the day. You can multiply in any order, That's the commutative property of multiplication. What if I don't know that, but I do know 4 times 15? That's 60. So you multiply in any order you want to. So now we have our formula. X equals negative b plus or minus the square root of jump all over 2a. And the reason I put the square root of jump, there's jump over there. We've already done that. So plugging into my formula, negative b plus or minus the square root of 4 is 2 over 2 times 3 is 6. There's your 2 answers. The first answer being negative 8 plus 2 divided by 6. The second answer being negative 8 minus 2 divided by 6. Negative 8 plus 2 is negative 6. Negative 6 divided by 6 is negative 1. And my second answer is not going to come out so nice and neat. Negative 8 minus 2 is negative 10 divided by 6. And negative 10 won't divide by 6 without giving you a decimal. We don't want decimal answers. We want nice, neat fraction answers. So since that won't divide, again, remember division and fractions are one and the same. They're identical. This is a division problem, but not only is this a division problem, it's also a fraction. So treat it like one. Since it won't divide, reduce it. Negative 10 divided by 6 is the same thing as negative 5 divided by 3. Segment addition postulate. You already know this, by the way. I've been there, done that. Here's what the segment addition postulate says. I'll tell you what, this is it. This is the mathematical version of it, and it might not make sense. It says if B is between A and C, here's B, it's located between A and C, then this must be true. AB plus BC is equal to AC. Another name for this is, I'll say this a lot, the sum, or excuse me, let's try that again. The whole equals the sum of the parts. And like I said, you already know this. You've done it, I promise. Whenever we start working it, you'll recognize it. The whole is equal to the sum of the parts. And that's the reason I have these two pictures here. You think about a whole apple. You take 4 slices, slice it up, put it back together, it's still an apple. Same way with a puzzle. The whole is equal to the sum of all the parts put together. Here's what it means. Let's say this is a road. You start out here at section. You travel 10 miles down the road to a gas station. You get gas. Then you get back in your car and you travel 50 more miles. All of a sudden you're in the hospital. Assuming it's a straight road. How far did you travel? 60. You know that. Okay. If the two pieces are 10 and 50, the whole thing is 60. What if I did it backwards? What if I said that you traveled 5 miles, but in all, you traveled 30 miles? 5 miles plus, well, if the 30 is the whole thing, then 5 miles plus another 25 probably would get you to 30. That's what it means. If you have line segments, the pieces, when you add them together, will give you the whole line segment. That's easy, man. So here we go. B is between A and C. I always draw it. So here's A, here's C, B is in between somewhere. AC is 14. That would be the whole thing. AC is 14. BC is 11.4. I need to know what AB is. Brianna, how am I going to find that? Just subtract, that's it. Subtract the 2. And we get, you got to subtract it down. Does anybody have it subtracted? Means AB must be 2.6. Just subtract it. S is between R and T. Find the length of RT. You might want to, on this problem, you might want to put a big star on this. We're starting something today that you're going to be doing the rest of the year. It's not going to be in this exact form, but the process that you're about to go through, you're going to do the rest of the year. The whole is equal to the sum of its parts. If S is between RT, that whole theorem says, well, if you took RS, you took this distance, added it to this distance, then you're going to get the whole distance. In this case, it's an equation. The distance from R to S plus the distance from S to T has to equal the whole distance. Everybody see where that equation came from? The whole is equal to the sum of its parts. The parts here are 2x plus 7 and 28. If you add those two parts together, you're going to get the whole thing 40. That's how you work those other problems. Question. Could I set this equation up different? On that last problem, you actually took the whole thing and then subtracted off one part to give you the other part. Could I set up this equation, 4x, take away 28, let me write this down, because it's hard to just think through it. Could I have wrote the whole thing minus 28 will give you 2x plus 7? Could I also set up the equation like that? What do you think? Sure. Move 28 over there. How do you move 28 over? You plus, you make it a minus. Is that not the same thing? Okay, so that is legal. So there's more than one way to set these up. And now what do? I just solve. That's the reason we went over linear equations. I'm going to move all my x's to one side, and I'm going to move all my numbers to the other side. They're already over here. Plus 28 and plus 7, we're going to put those together. 2x becomes minus 2x. Caitlin, how many x's am I left with? 4x minus 2x leaves me with. Good. And 28 and 7, Caitlin, is plus. Careful. We didn't change it, so 35. Divide by 2 gives me x is 17.5. Guess what? That's not what it's asking, is it? It didn't say what is x. It says what's RT. Once you solve an equation, okay, x is a variable. X is an unknown. Is x now an unknown? No. X is no longer an unknown. X is now a known. We know that every x is equal to 17.5. So up here where you have 2x plus 7, 4x, those are no longer x's. Every one of those x's are now 17.5. So let's redraw that up there. So you have RT with S in between, so RST. This was 28. Let's go ahead and put it there. 2x plus 7. Like I said, 2x plus 7 is no longer 2x plus 7. What I want you to start doing, take these x's and plug them in. Somebody's got your calculator, instead of 2x plus 7, type in 2 times 17.5 plus 7. 2 times 17.5 plus 7 gives you a total of, is it 42? Is that right, 42? Okay, now, the whole thing, RT is no longer 4x. It is now 4 times 17.5. Type it in. What do you get? 7. If you do what I just did, it's nearly impossible to miss these problems. Because look what you have now. This is 42, this is 28, this is 70. How can we check this? This is 42 and this is 28. Does that add up to 70? Yeah. If x had been something different, that is the only x value that would satisfy that. What if I got x equals 10 and I plug that in? Look what happens. Okay, that one checked out. But what if I get a wrong answer? Let's say that I think x equals 10. Plug those in. RST, that means 2 times 10 plus 7, that'd be 27. This is 28. 4 times 10 is 40. Is that true? No. That's the only x value that satisfied that equation. Anytime you get an x and you plug it in, you can check every one of these problems. Like I said, you should never miss one. This one says, suppose that PR, which is the whole thing, PR is 47. We need a relationship. We need to find out what's the connection between these P, and we know whole equals the sum of the parts. If I add PQ to QR, it's going to give me that whole segment. So 4x minus 1. Rachel, help me finish setting this up. 4x minus 1. If I add this piece to this piece, so plus what? Will equal the whole piece, which is what, Rachel? Good. There's your equation. The whole, or the sum of the parts, is equal to that whole. We solve it, we're done. And on this one, it's actually asking you to solve for x. So they want you to give x, and they want you to give PQ and QR. Let's keep our x's together. Since we have 3x already over here, let's put it with the 4x's. Mark it out. Minus 1 and minus 1 move to the other side. Can I just put plus 2? How about you? Because you're going to do plus 1 and plus 1, the same thing as plus 2. So it gives me 7x's equals 49. So x must be 7. So let's check. If x is truly 7, this is no longer 4x minus 1. X is no longer an unknown, x is now a known. So 4x minus 1 is no longer 4x minus 1, it is now 4 times 7 minus 1. 28 take away 1 gives me 27. 3 times x minus 1 is no longer 3x minus 1, but 3 times 7 minus 1, which is 21 minus 1, which is 20. They told me in the instructions that the whole thing was equal to 47. Does that check out? Is 27 plus 20 equal to 47? Yes, it is. Another definition. The definition of bisect and the definition of midpoint. Hey, we bisect in science, right? We bisect in science. We dissect in science. We cut in science. We cut up. We don't bisect. Although bisect, and I guess that means SECT, what I would say means to cut. But we're doing a different kind of cutting here. What does bi mean? 2. So what do you think bisect? How are we going to cut it? Into 2 pieces, but there's going to be something special about those 2 pieces. They're going to be the same. When you bisect something, you cut it into 2 equal pieces. So how do you trisect something? You cut it into 3 equal pieces. Wait a minute, what's it called when you cut it into 4 equal pieces? I don't know. I have no idea. So what's the relationship between bisect and midpoint? You've done midpoints before, right? Somebody give me a really good definition of a midpoint. But you only get 2 words. What's a midpoint? It is the, thank you. It is the middle point. Hence the name, midpoint. So what's the connection between bisecting and a midpoint? I'll tell you this, in this figure, XY, line segment XY, bisects line segment AB. And if XY bisects, which notice the tick marks, that's how I knew that. That means that this is equal to this. Let's call this C, I guess. If XY bisects AB, what is C? Is it not a midpoint? That makes sense. So what's the relationship between bisecting and midpoints? Well, if something bisects a line segment, it has to pass through its midpoint, its middle point. And again, a middle point is the point that's directly in the middle. Now, is C the midpoint of XY? We didn't say that. XY bisects AB, it cuts AB in half. I don't know, C might be the midpoint of XY, but we're not given that. Okay, with that said, this one's a little different. Before we were using the segment addition postulate, we said 2x minus 7 plus x plus 17 equals the whole thing. That's fine. But we're not given what the whole thing's equal to. we are given, suppose that AB is congruent to BC, which means that if this is congruent to this, B is a midpoint. You need a relationship. You need some sort, and that's what it's going to be this whole year, is you're going to be given a figure, and pretty much on your own, you're going to try to find the relationship between the parts of the figure. This one pretty much just flat out tells you. AB is congruent to BC. B is the midpoint. If I drew a line segment down through here, it would bisect it. If AB is congruent to BC, that means that 2x minus 8, let's try it again. 2x minus 8, what would I put next? 2x minus 8 is equal to, good, x plus 17. You're not always going to use the segment addition postulate. That's the reason I follow that up with this. Just because the figure looks like that, the shape looks like this, doesn't necessarily mean that you've got a segment addition postulate problem. This says that this is congruent to this. If AB is congruent to BC, then 2x minus 8 is equal to x plus 17. They've got to. They have to be the same length. They have to equal. Move the x's one way, move the x's the other way. Now, if you're getting better at solving these equations, I think I told you to begin with, you don't have to show me minus x, you don't have to show me plus 8. If you can just do it in your head, awesome. When you do minus x over here, how many are you left with? 1. Equals, when you do plus 8, anybody do 17 plus 8 right? Perfect. So look, you just solved that. X is 25. And if x is 25, Jordan, AB, that'd be 2x minus 8. If x is 25, what's 2 times 25 minus 8, Jordan? 2 times 25, 50 minus 8. 40, what? Good. And if I'm right, let's see. 25 plus 17, anybody got that done yet? 42, it better be, right? That's the only x value that when you plug it in, makes those two sides equal. So since I got 42 and 42, how confident am I about my answer? I'm right. Okay? There's no doubt in my mind that's right. Because when I plug them in, I got the same values. That's what I was looking for. What makes them equal? Obviously, it made them equal. Now, how in the world am I going to find AC? There you go. And that was called the segment addition postulate. Since AB is 42 and BC is 42, the whole thing is 84 by the segment addition postulate. I'll be asking not only is it true, but you might want to write that down. I'm going to be asking why it's true. The segment addition postulate. And I told you the other day, postulate, I don't know if you noticed that, postulate's a common sense phrase. Why do we know that the segment addition postulate is true? It just is. Okay? We can kind of just tell and see. It's common sense. Suppose that AB is congruent to BC, meaning that B is in the middle. Solve for x, find the length of AB, BC, and AC. We have, this is x plus 6. The whole thing is 3x minus 31, but we're not given a BC. There's two different ways to set this up. The first way. What is this? BC. Is it not also x plus 6? There's one way to set it up. And now since this is equal to x plus 6 and this is equal to x plus 6, by the segment addition postulate, x plus 6 plus x plus 6 has to equal 3x minus 31. The whole thing has to be the sum of those two parts. Now from what I just told you a while ago, what if this were 8? The whole thing would be 16. How did we find that? Did we not just double that? So another way of working this is if I double AB, does that not tell me what the whole thing is equal to? How in the world do you double x plus 6? Somebody want to take a stab at that? Somebody double x plus 6 for me. Not squared, but 2x plus 12. That's double, right? If you double AB, it's going to be the same length as the whole. Okay. Now let's solve. And honestly, we don't have to solve both. Guys, x and x, 6 and 6, is that not the same equation? Yeah, it is. So let's go over here and let's just solve the second one. And we can do it in our head. Let's take 2x and move it to the right side, where you have 3x's. 3x's, and since this is a plus, as we move it, it's going to be a minus. 3x's minus 2x's give me 1x. We like those. When there's only a difference of 1, it's going to be pretty easy. That's going to be the only step. Minus 31 moves over here by doing plus 31, and I get 43. So x must be 43. Which makes AB no longer x plus 6, but 43 plus 6, which is 49. BC is the same thing. And if I did it correctly, there's two different ways to find AC now, isn't there? Either I can add 49 to 49, it gives me 98, but I want to check myself and make sure I'm right. Instead of doing that and get 98, let's plug in 43. And if I get 98, I must be right. 3 times 43 is 129. 129 minus 31 gives you 98. It checks out.